Hi everybody, in this video we're going to take a look at how can we assemble this contraption that we see here. We're going to use a stem board, we're going to use a breadboard, some resistors, a little buzzer, we're going to use some wiring and an LED that's a tri-LED which has three colors like red, blue and green, and it can change into different colors. Here I have it set up in red, yellow and green. Right, there you go. And the buzzer buzzes once on the red, twice on yellow and 3 times on green. And we're gonna take a look at how all this gets set up. All my pieces that you see here are from this kit, the PiBot kit. Okay, the very first thing before we start building anything, let's take a look at our LED. My LED is rated by the factory to be at 20 milliamps. This is the current. Okay, so we're gonna use V equals IR, voltage equals current times resistance. And in our setup, we're gonna have a 5-volt voltage source. Okay, so in order to don't destroy our LED, we need to make sure that we're not gonna exceed 20 milliamps. For this, we're gonna use this equation, solve for R, voltage over I, 5 over 0.020 amps, and this will give me a value of 250 ohms. Now, I do not have a resistor with 250 ohms, but I do have one that is 330 ohms, and this is the one I'm gonna use. So what this changes from here is that if we use a little bit higher resistance, all it's gonna do is not gonna allow the LED to shine at its brightest. So it's gonna be a little bit dimmer than its maximum. If you would use a resistance that's less than this, that's not good, because that would mean that we have bigger current going through the LED and it will burn out. So make sure that you will use a resistor that's bigger than this, equal or bigger. I'm gonna use 330. This is how a rough sketch of my system will look like. We're gonna connect to the stem board at these points, which will be basically our voltage sources. We're gonna insert our resistors, our LED, and so we can see it better. This is a tri-LED, so it has 3 LEDs in one, so it has 3 colors. I'm gonna connect, let's say, the red to here. I'm gonna take the blue to the middle, and I'm gonna take the green to this point. And then the 4th wire, which is the black one, is gonna go to the ground. Okay, now, and down here we have the buzzer, which it will not need a resistor in the middle. It will just be straight plugged in. Okay, and let's take a look at the stem board. Okay, this is how it looks, and as you can tell, these are the red wires that I'm plugging into it, and you can tell that every port over here, it's numbered, and that's why it was important to know which one goes where, because this will matter a lot when you write your code. So port 11, 10, 9 and 6 will be used. And on the other side, I'm gonna be using the black one, which will go into the ground. It's very simple to make the connections. I'm gonna connect the buzzer to 0.6 right now, and that's pretty much it. And then these wires, we're gonna bring it to our breadboard. This is coming from, let's see, gonna come from, this is 11, this is 10, and this is 9 right here, 11, 10, 9, and over here is the buzzer, as you can tell. And it comes into the breadboard. It moves this way. So I'm gonna, after it goes in, I'm gonna put my resistor, which comes to the other side of the breadboard and continues, and this red light is gonna go for the LED. Same thing from point 10 goes to the resistor, then goes to the blue line of the LED. Same with the point 9 resistor, green line of the LED. And now we have the buzzer. It does not need a resistor, so it just goes in, red line, buzzer, and ground on the other side. And here, red line of the ground from the LED. Sorry, black line from the LED comes into the ground. From here, the buzzer comes, and then this line, the very last one, all connects back to the stem board over here at the grounding point. Okay, this is pretty much the way we set it up, the hardware. And my voltage source to the board is gonna come from our USB drive from the computer, which we plug in right here. And now we are ready to go ahead and write our software. I already wrote it and uploaded it, so that's why it's doing it. But if you haven't wrote it, then probably it's not gonna do anything. I'm just gonna wait for you to write something. Okay, here's the Arduino code. I'm gonna put this in the description of the video as well, so you can have an easier way reading it. But roughly, to explain how it's done, remember our ports from the stem board, the 11, 10, 9, and 6. This is where we tell the software that this is, when we tell them something, we want it to connect to this port, or this port, or this port, or this port. So that's why we write define the green LED, since that one's connecting from port 11. The buzzer connecting from port 6, so we're going to define it as such. Okay, further down here, these are explaining the hardware that our values will go from 0 to 255, because here I changed this tricolor LED. I'm not using a blue, the middle line, which is blue. I changed it to green, actually yellow. Change it to yellow. So therefore we're gonna do some adjustments to get a yellow out of the blue. So let's see. This is the first part where we control the red LED, and the only one active is the 255. That's the maximum value for red. I want the other two to come on as 0. So only the red wire with the red LED, I want it on, and that's it. I don't want anything coming from the blue or the green wires. Then we plug in our buzzer to beep once, and I have the same thing here as I have it here, and that's because I want the light to start showing, then I want to hear my buzzer, and then I want, but the buzzer I want to be very close to the beginning of the light. So light starts, buzzer goes on, and then light continues for a longer delay. Here you can see 4000, here was only 100. And then on the end we just simply tell that turn off the red, the blue, the green, everything, turn it off. This part is done. I'm gonna move on to the yellow part. Now the yellow part. We do not have a yellow wire, so we have to combine the red, blue, and green in such a way that it gives the effect of yellow. So by trial and error, pretty much, the code is pretty much the same. Nothing changes. The only thing that changes is how much you want to turn on the red, the blue, or the green. So I decided to turn on my red wire, so the current in the red will go, but not all the way to 255, just 230, so a little bit less than full. I don't want any blue, and I want just a touch of green that will help turn the red into yellow, and that's why I put only 30 instead of 255, which is maximum. So there you go. This will help me to get yellow. And you can play around with these colors. You can get purple and all kind of colors. So this is where you would play around with it. And don't forget to change it here too, since in this code I put it in twice. You can take one out if you don't like this order. Play around with the orders, see how you like it. And on the end, I have the green section, the green LED, which is pretty much the same thing as it was in the beginning for the red. Just over here, when we tell what we want to turn on, we tell I want the red 0, blue 0, and I want the green at maximum. And let's see, that's pretty much how at the end we turn it off and give it a delay 50, a very short delay, and then it'll loop back to the front and start with the red one again. Now we can go ahead and upload it to the device. There goes the upload. And when it tells us that it's done uploading, our device will start working. And this is how it looks. Red with 1 beep, yellow with 2 beeps, and green with 3 beeps. And you can play around in the software with the delay times, and that way you can get shorter, longer red, or bigger beeps, smaller beeps, however you like it, or different colors.